This video discusses the process for developing annotation schemata. It covers defining annotation categories and writing annotation guidelines, and works through a case example to more concretely illustrate how this might work. This video is the third video in a series of videos covering the typical data collection pipeline, focusing on developing annotation schemata. If you haven't watched the first two videos yet, you may want to go back and watch those videos before continuing further. Developing an annotation schema for your task is crucial to ensuring that you are able to collect high-quality annotations that allow you to move closer towards realizing your project goals. Once you've modeled your problem and determined your dataset specifications, it's time to start building your dataset. The first concrete action towards doing this is to create your annotation schema. An annotation schema defines the actual labels that annotators will be assigning to data instances and provides instructions to help them understand when different labels should and should not be assigned to a given instance type. Developing a clear annotation schema can mean the difference between acquiring reliable annotations with high inter-annotator agreement that conform to your initial goals and acquiring poorly agreed upon labels that do not align with your expectations. In creating your annotation schema, you'll need to answer a variety of questions about your planned dataset. You should determine what the annotations will look like, how the different types of tasks in your dataset, if applicable, will be represented differently, how you can maximize the usefulness of your corpus for the greater research community, and what types of constraints you'll need to work with, both in terms of your annotators and your downstream machine learning task. Constraints could be environmental factors, such as your annotation interface. If you're using Amazon Mechanical Turk, for example, you may not be able to fully control some aspects of what your annotators are looking at or record certain types of information, so it's important to take that into account when devising your annotation schema. You also need to make sure that you keep your data accessible from a developer standpoint. Building datasets is a tricky and time-consuming task, so unless you're working with protected data, there's a good chance you'll want to share your dataset publicly at some point, both to facilitate reproducibility and to get a bit of recognition for your contribution. Requiring that the data be accessed through an intricate database system or that it be labeled using a complex XML schema can make it challenging for third-party researchers to leverage the data in their own projects. If you do either of those things, make sure to document the setup process extremely thoroughly. Otherwise, you may want to rethink your schema such that the data could be provided in a simpler format, such as a CSV file. A key aspect of developing your annotation schema will be clearly defining the annotation categories themselves. Keeping in mind what was covered in a previous video regarding the trade-off between informativity and correctness, you'll want to define a reasonable number of annotation categories. For each category, you'll need to create a concise definition for it. The definition should clearly explain the data characteristics annotators should look for when assigning that label, in as few words as possible, since annotators have short attention spans just like the rest of us. The longer a definition is, the likelier it is that annotators will skim through it or overlook some parts. If possible, for each category, you should also include an example following the definition. It can be very helpful for annotators to see a concrete case in which data should receive a given label, rather than relying on more abstract definitions. To see how we might define an annotation schema for a specific annotation task, we can walk through a case example. Let's say we have a character, Natalie, who wants to collect emotion labels for a classification task. She's interested in working with Twitter data specifically and has already downloaded 1,000 tweets from the web that she wants to have labeled. She wants each tweet to be labeled with the dominant emotion that it expresses. She needs to create her annotation schema for this task, so the first thing she needs to do is decide upon a reasonable set of labels. After doing a bit of research, she decides to use Ekman's 6 basic emotion categories. She has a few reasons for choosing these from among other possible sets of emotion labels. They're easy to explain, they're not too numerous in that there are a total of 6 of them, And during her literature review, she finds that they're used in other data sets as well. So her labels for the task are happiness, sadness, surprise, fear, anger, and disgust. Now that she's decided on these labels, she needs to concisely define each one of them. It's not enough to just give these labels to the annotators without any further information, because they may have different interpretations of when the labels should be assigned. That would lead to unreliable labels and poor inter-annotator agreement. She creates the table here with very brief descriptions for each category. The table suggests that tweets should be labeled with happiness if they indicate happiness or joy, fear if they indicate fear, stress, or panic, and so forth. To make sure her guidelines are clear, she also downloads a few more tweets and finds examples for each category. This provides annotators with a concrete understanding of what an instance associated with each category should look like. Our character Natalie is getting close to finishing her annotation schema, but she needs to add some overall instructions to annotators so that they know exactly what they're doing with these categories, rather than just guessing based on the definitions and examples. Once again, when writing instructions, you should be as concise as possible, since the shorter your instructions are, the likelier your annotators are to actually read them. You should also ensure that the instructions state everything necessary to complete the task, even if some of the details seem very obvious to you. That's because by the time you're developing your annotation schema, you've probably already been thinking about your research problem for quite a while. In a sense, you're the world's foremost expert on your particular annotation task. Your annotators will likely be much less familiar with the task than you, though, so you may need to explicitly state things that you might expect someone with your level of expertise to infer. So our character writes the instructions you see here, publishes the task with a small pilot sample of data, and collects annotations. Now, remember that building a data set is often an iterative process. You may not always hit upon the optimal annotation schema on your first try, and in fact, it's unlikely that you will. That's why, as mentioned in a previous video, it's good to start out with a small pilot sample of data and check both inter-annotator agreement on it, as well as agreement with what you, as the foremost expert on this task, would ideally like to see. If agreement is poor, or if the labels don't match with what you'd like to see, you can revise your schema before moving forward. If you have access to your annotators, you can ask them for feedback about the task to see where some of the potential pitfalls might be. For example, did they feel like an important category was missing? Did they feel like there were some categories that could easily overlap, making it hard to choose between them? Was the annotation format reasonable, or was it cumbersome or unintuitive? Our character hits a bit of an unexpected hurdle, but she's not too worried because she knows this is very common. Specifically, she finds that the inter-annotator agreement for her pilot sample of data is lower than expected, and that when reviewing the annotations manually, a lot of tweets seem to be incorrectly labeled with happiness. She asks her annotators for feedback on the task to get a sense of what may have gone wrong, and compiles their responses. Their feedback is insightful and quite useful. One of them indicates that they just chose happiness as a default when they couldn't really detect any emotion in the tweet, and the other indicates that they had trouble distinguishing between whether tweets expressed surprise or fear. Taking that feedback into account, our character updates her description of fear so that it is more distinguishable from surprise. She also adds a new annotation category, neutral, to be assigned when a tweet expresses no obvious emotion. She adds an example for the new category, just like the other categories. Now, she can solicit new annotations using her revised annotation schema, check agreement and quality again, and either move onward to soliciting annotations for the full dataset, or otherwise continue to revise until good performance is reached on the pilot sample. If you're struggling to create a good annotation schema that yields high-quality annotations, Related corpora in your task area can be a valuable resource. If there are already well-defined standards in your task area, you can use those to the extent possible, which will also foster easier adoption by other researchers. If there are well-defined standards but you choose to deviate from them, make sure to document your reasons for doing so. Others interested in the corpus will almost certainly ask for justification before employing it in their own work.